Okay, this video is going to go over example number 2 in your foldable. So make sure you have your foldable. We're going to be on this tab that says Solving Algebraically, and we're going to be on example 2. You are also going to need your perfect square bookmark if you have it, and if not, please ask us for one of them. We made extra copies. Okay, so we're going to do example 2. And what we're moving on to is solving algebraically. And there's a very specific reason why we would want to solve algebraically. And you're going to see why in this problem. So before, what would happen is we would have a polynomial like this one, and you would go into Desmos and put it into Desmos. So that's what I did. I put this polynomial into Desmos, and this is what the graph looks like. And this is the full graph. I'm not missing any roots or anything or x-intercepts that you can't see. This is it. So what's different about this, and this is what we're going to write on our paper, is I actually can't see all the roots. Well, how do I know how many roots there's supposed to be? So the first thing you're going to do is you're going to look at your highest exponent. And your highest exponent in standard form is called the degree. And what this number does is that it tells us the number of solutions. And remember, we also have called those roots. So just looking at this, it looks like I should have 3. But looking at that Desmos graph, I only have 1. And there's a very specific reason for that, and that is the other 2 solutions that you cannot see are imaginary. And that is the reason we have to do it algebraically. We cannot get our imaginary solutions from this graph. But what we can do is use the information from the graph to help us find the other 2 solutions. Okay, so you'll notice this first part is already typed here for you. Enter the polynomial into the graphing calculator if you are not provided a root or a factor. So that's what we just did. And actually, we're going to number that step 1. That's what we just did. Well, I did for you. You don't have to do that. Number 2, at least not in this problem. The next thing is you have to name the root. You're going to name a root. Now, we've made these problems so that there is at least one integer root that you can find. An integer is a whole number and its opposite. So you should be able to find one nice root. And in this case, we had x equals -2. Once you have your root, we're going to name that as a factor. So if my root is x equals -2, the factor that would go with is x plus 2. Now, the reason we're going to name the factor is because of the type of division I'm about to do. I need the factor. And that's what the next step is. We are going to divide. Now, in this video, the division that I'm going to show is box method. So if you don't use box method, you can kind of, just kind of skip through this part and do the division that you know how to do. But you want to make sure that you get the same quotient that I get using box method. Okay, but before we go too far, I want you to kind of split this paper in half, because we're going to put the division work on this side, and then we're going to use quadratic formula, so we need the space on this side. So don't write right in the middle of the page. We need all of the space. All right, so I'm going to do my division. So what exactly am I dividing? I'm going to take this original problem, so that's going to be our dividend. And I know I need 3 vertical lines because that is my highest exponent. And I'm going to divide by this factor that we found. So I'm going to line this up so that my diagonals are lined up with my like terms. And now I can actually do the division. So again, if you don't do box method, don't write down box method. If you do synthetic or if you do long division, then you'll do that in this box. So I write this first term first. X times x squared gives us x cubed. I'm going to multiply my row and my column. And now I can subtract to find my diagonal. This is x squared. And then I start it again. X times x gives me x squared. Multiply my row and my column. And then I subtract my diagonal. Last column here, 1 times x gives me 1x. 1 times 2 gives me 2. And if you notice, I have a remainder of 0. The remainder must be 0 before you move on. It must be 0. And why is that? That's because, remember, by definition, if I have a factor, it has to have a remainder of 0. And if my factor is right, then something must have gone wrong in here if you don't have a remainder of 0. So this is kind of like a checkpoint to stop and go, okay, can I move on or not? If my remainder is 0, I'm going to move on. If it's not, you got to check your work to make sure that you did that correctly. All right, and then our last step, we're going to come over here to this blank area. And we are going to use quadratic formula. We're going to use quadratic formula to solve this remaining quotient. So this is actually what we're going to use. That's going to give us our A, our B, and our C. Now, I know that's a little weird because they're all ones. Is it always going to be like that? No, definitely not. That just so happens to be this problem. So again, I want to be really clear about where these came from. This came from the quotient. So when we use quadratic formula, we use the A's, the B's, and the C's. And those A, B, and C come from in front of the x squared, the x, and then the constant. So remember, there should not be any x's or x squareds when we actually put stuff in the formula. So that's what we're going to do next. I'm going to take my A, B, and C, and I'm going to sub them in. So x equals the opposite of B plus minus B squared minus 4 times A times C. And all of that is over 2 times 1. All right, so now I've got to simplify this. The opposite of 1 is negative 1. We still have that plus minus, and all of this is over 2. Now, I want to remind you that when we do this step, what I put in the calculator is just the stuff under the radical, no radical sign. So this goes in the calculator. This goes in the calculator, no radical sign. So when I actually put this in the calculator, I get negative 3. All right, but I can't stop there because I cannot have solutions that have a negative under the radical. So I'm going to have to simplify this. This negative 1 doesn't change. All this over 2 doesn't change. I'm going to break this down. If I have a negative, I'm going to take that out first. And remember, the reason I do that is because I'm trying to break everything out of the radical that's possible. And one of the things I can break out is the square root of negative 1. And it's going to become I. Then I'm going to find the largest perfect square that goes into 3. Now, 3 is not a very big number, and the only one that's going to work is 1. Well, that means my leftover is 3. All right, so I'm almost done here. I'm going to simplify all of these. I have a negative 1 plus minus, all of this is still over 2. All right, the square root of negative 1 becomes I. The square root of 1 technically is 1, so if you want to put the 1 there, you can. You don't have to. You just leave the I by itself, and then you've got a radical 3 at the end. You cannot take radical 3 out. You can't simplify. It's going to give you a decimal. It's an irrational number, so that's why it stays just like this. So, but what I want to reiterate here is, and hopefully you can pause it right now and ask your teacher for a Post-it if you didn't get one. But we're going to take the Post-it and we're going to put it right in the middle so it's very clear what the answer is here. Because the directions were find all the solutions. So I'm going to list the solutions here. Because this is a lot of work. I want to make sure you know what the actual solutions are. So the first solution we found from the graph, it was negative 2. The other solutions we found are down here, and this is actually two different solutions. So I'm going to show you, we're going to write it with the plus. And like I said, you don't need the 1 there. And I'm going to write it with the minus. Because this whole time we've actually been finding two different things, except it's just a lot more efficient to write it once with the plus minus sign there instead of writing it twice, all with the plus and then all with the minus. So these are our actual solutions. And remember, sometimes we call these roots. So sometimes the directions might say, name the roots, or it might say, name the solutions. So this is what it looks like.